we ran out of time in one of the periods to show how to make this particular function continuous at x equals 1, but it's probably good to have a record of this stuff for you guys to look back anyways. So I don't know. I don't even know why this thing is not continuous right now. Probably because k hasn't been defined. Let's investigate. So I'm going to factor out x squared minus 3x plus 2 and x squared minus 4x plus 3. Okay, there we go. So that's when x isn't 1. When x is 1, we use k. Oh, and that's our job, to figure out what k is. Maybe let's draw a sketch of what we know. 1, 2, 3. Let's get another color. So based on this pair of x minus 1s, we can't put anything at x equals 1. Well, it's going to be a k value, but if we're just graphing x squared minus x plus 2 over x squared minus 4x plus 3, well, that's what we get. Okay, let's put a 1 on here, negative 1 on the y-axis. What do we know? Oh, well, we know 2 would make f equal to 0, so f is going to have an x-intercept at 2. When x equals 0, f is going to be 0, 0 plus 2, 0, 0 plus 3, 2/3. Most of us are going to recognize f has a vertical asymptote at x equals 3 and a horizontal asymptote of y equals 1. I could draw over here, but we don't really care. We're only worried about what's going on near x equals 1. So I suppose the situation is we know this dot, this yellow dot, I guess right now f is continuous, but we just don't know the value of k. Right? We need to know that height of k, and based on what I know about graphing, I'm relatively certain k is positive and less than, not just less than 1, but less than 2/3. So we're preparing you for taking the AP test. When you see that keyword continuous, we need to refer to the definition of continuity. So let's say if f is continuous at 1, oh, that's not where the t goes, then we would know that the limit as x approaches 1 of f of x should be equal to f of 1. And that's just definition of continuity. All right, I don't know how that's going to help me. Oh, when x equals 1, f is equal to k, right? That's what it says. Okay, so I can make that substitution. We'll just leave the limit as x approaches 1 of f is supposed to be equal to k, right? That's over here. And then I think I'm going to imagine doing a numerical limit to evaluate the limit as x approaches 1 of f, but I'm going to use a slightly easier to use format. I'm going to use the factored form. Okay, and we still need r equals k. So if we can figure out this limit as x approaches 1 of the quantity x minus 2 times the quantity x minus 1 over the quantity x minus 3 and the quantity x minus 1, we're going to know k. So what I want to pull your attention to is this pair of x minus 1s. Okay? X minus 1 over x minus 1 is almost always 1. Almost doesn't matter what number you put in there. If we use 0.9 minus 1 over 0.9 minus 1, of course that's the same number, equal to 1. 0.99 minus 1, 0.99 minus 1, that's a number over itself, again equal to 1. We could even choose a number like 1.1. we get 1 again. So really, those x minus 1s don't matter. We can ignore them. Okay? I don't really think it's a good idea to cross them out, although some people will tell you to cross those out. I'm just going to ignore them temporarily, and we'll get rid of those x minus 1s. They only matter when x equals 2, and hopefully you know, when x equals 1. The x minus 1s only matter when x equals 1, but hopefully you know that when we do a limit as x approaches 1, we're not using exactly 1. We're using numbers a little bit less than 1 and the numbers a little bit more than 1. Well, look at what's left. All we really care about is x minus 2 over x minus 3. And, well, that expression doesn't have any problems at 1. So 1 minus 2 is negative 1. 1 minus 3 is negative 2. So I guess k is equal to 1/2. So I'm just going to get rid of this blue stuff right here so you folks can read. And that's all we need. Our job was to find k, and the last thing I wrote is k is 1/2. I think we're good to go. You may want to graph. What would I graph? I guess I would graph x squared minus 3x plus 2 over x squared minus 4x plus 3, and then I'd graph the ordered pair 1/2, maybe in Desmos. That's probably the easiest way to check. Okay. And then the other thing I want to point out, look, this 1/2 makes sense. This 1/2 syncs up with what I was thinking beforehand. I thought k was going to be positive and less than 2/3, and 1/2 fits the bill. So at least that doesn't sound like a crazy answer. I hope that helps.